Welcome everyone to today's webinar, Master REST APIs, the Universal Integration Tool in AI and Beyond. My name is Nikki and I'm a Marketing Event Manager for Developer Initiative here at Oracle. Today we'll guide you through the basis of REST APIs and demonstrate practical applications across various tools and services. If you have any questions during the webinar, please drop them in the Q&A. That'll help us identify unanswered questions. We have also set up a Slack channel, Cloud Coaching North America, in our developer workspace that you can access at the QR code or the link on the screen. And before I pass it off to presenters, I wanted to let you know we have more amazing webinars just like this one coming up next month. You can check them out using the QR code or with the link. And today's webinar will be presented by our amazing presenter, Derek and Steve. Without further ado, I'll pass it to Derek.
Yeah, so hello everyone and welcome to our presentation on REST APIs. Joining me today is Steve and Nichols. Steve and I both work on the Code Innovate team, working with customers every week to build solutions to their use cases. And many of those use cases involve using multiple services and require REST APIs to exchange data between them. And so we've learned a lot over the last few years, and we just thought we'd put together a webinar and share that with the greater Oracle community. I wouldn't say we're experts on it, but we're more like practitioners, and we just wanted to share all the lessons learned over the years. And and we'll be starting. We don't assume you know anything about REST APIs. This is going to be very, very slide light. We're going to be mostly hands-on. I think most of you prefer that. And I'll kick off with a very brief introduction to REST APIs in general, and then I'll hand it over to Steve. And Steve's going to walk through the API fundamentals using Postman. Postman's a very popular tool for testing and working with REST APIs. He'll show you how to use that. He'll also cover executing REST APIs using curl. Curl's available on every Linux machine. I use a Linux desktop. I can just, if I want to test a REST API, I can just issue a curl statement. Very handy for doing that. And he's then going to go into autonomous database support for REST via util HTTP. Util HTTP has been around for, I think, at least 22 years. I've been with Oracle 27 years, so it was around 2002 when it came out. And more recently with cloud databases, DBMS Cloud Package, very handy package of doing a lot of different things, including issuing REST calls. And so he'll cover both those. And then he'll go into using REST for OCI Generative AI Services that use large language models. If you're going to be working with AI and large LLMs, you're probably going to be using REST APIs. So this is going to be handy information for when you plan to do that. And then I'll come back and show a couple of instances where we use it in our other services, things like OAC, Apex, and then show you a custom application built using REST APIs to generate transfer data using Golden Gate services. And then finally, I'll pass it back to Pete Madura. Pete's also on the Code Innovate team. He'll just talk a little bit more about the Code Innovate program. So first of all, what is it and why should we care? Well, REST is a way of providing interoperability between computer systems on the internet. You can define REST services to allow the querying and manipulation of data without the need to directly access the underlying data store. So for example, when I work with data integration, I typically create a direct connection to a database. While across the internet, typically we don't do that. And so you need REST APIs to bridge that. Some characteristics, data's modeled as resources identified by a URL, and they're accessed via HTTP or HTTPS using web protocols. A small set of operations. If you're going to issue a REST call, it's either going to be a put, a post, a get, or a delete. And we'll just talk briefly about when you use those. By their nature, they're stateless. There's no connection that's kept open between the client and server computing systems, and no client context is stored between the requests. And they always elicit a response. The response is in the form of XML, JSON, HTML, or some other service. Over the years, the only ones I've ever seen are JSON responses. If you're not familiar and comfortable with working with JSON, you can take a look at a previous recording we did focus exclusively on JSON, but you'll be seeing some of that today in any case using the JSON payloads. And then depending on the operation, response provides some sort of detail on the alteration of the underlying data, error message, etc., hyperlink links. Recently, we had a customer who wanted to create run a report from PeopleSoft. They use a REST API to run the report. It returns a job ID. Then you issue a status call to see if the job is finished or not. And when it's finished, it issues the URL for where the file is, the report is, and where it's landed. And so there's this interaction back and forth in REST APIs between the request and the responses. The vast majority of Oracle services, cloud services, support REST APIs, providing interoperability between them and with external applications on other cloud providers. I've just taken a screenshot of the API reference manual. It's really handy. All the APIs for all the services in OCI are all in one place. This is going to be your go-to guide when you're going to be working with REST APIs. Really handy place. Locate that and bookmark it. And just briefly, REST operations. If you're going to you'll use a put operation if you're creating or modifying an existing resource. If you're creating a resource, you're going to use a post. If you're going to get data, you're going to use a get statement. Head is very similar to that, although I've never actually used the head myself. And then delete. If you need to delete a resource, you use a delete operation. So it'll be one of those methods. I said this is going to be presentation slide light, and so I'm done with my slides, and let's get right into the hands-on. Steve, over to you.
Great, thank you. Again, thank you, Derek, for setting up the rest of the demonstration here. Again, my name is Steve Nichols. I'm part of the Code Innovate team, and like Derek said earlier, these are all examples of REST use cases that we've had recently, and we thought we've seen enough of them that we might package them up together and present them today. Don't worry, you don't have to take notes throughout today's webinar. It'll be recorded and sent out, and I also have a GitHub Markdown cheat sheet that I'm showing right now that will be sent out as a link as well that contains all the PLSQL, links to documentation, SQL statements, and so forth. And this is just a link up to it right now. But normally when we start working with REST, one of the first things I do is I go straight to Postman, whether it's a REST OCI call or a REST to a third-party provider. I found that Postman works really well for working out the kinks, testing the payloads, making sure the endpoint's correct, authentication's correct, and so forth. And so I go to Postman. If you're working in OCI REST APIs, like Derek showed earlier, we have you covered. Oracle Developers maintains all the REST APIs for OCI in Postman. And this is what I'm showing you here is if you go to postman.com/Oracle Devs, you'll see all the collections, APIs, and workspaces available for you to export and play with. I usually go to the workspaces, and then inside workspaces, there's a Oracle Cloud Infrastructure REST APIs. And you're going to see that this is going to line up very similarly to the documentation link that Derek showed earlier in the presentation. And you'll see all the API calls here. This is where I go to get the endpoints, what's required in the payloads, what's not required, the values, and so forth. But when you look at Postman, you can see all the services that we cover in the API world. You can export all these. What I typically do is if I'm going to work with a new service that I haven't worked with before, I'll come up to the service that I want to, and I'll just go export. it'll just export a JSON file. And then I'll import it into my local Postman installation when I'm ready to use it. But before I leave the Postman website, I just want to call out, and I'll cover this in a few minutes. They walk through how to set this up. And so they talk about the REST APIs, the endpoints. This link is going to take you back to what I just showed you. They also walk through how to set up the Postman environments and API calls so that they work properly. And if you're familiar with OCI and if you've used the OCI CLI before, the command line interface, some of these values will start to look familiar. You'll need, anytime you make an API call to an API, you'll need all the OCIDs along with the fingerprint, private key, and region, and so forth. And so now that I've exported out a service, what I'll do is I'll jump over to my Postman installation on my local machine, and I can say import, click the file, and then there's the API gateway that I just exported out of the Postman website. Click open, it'll import it in, and now it's available for me to use and call. Now I'm not going to use that one today, but I just wanted to show you how easy it is to go from the website to your local Postman environment. So now that I'm in Postman, I have whatever API collection I'm going to work with. One of the first things you need to do is go to your environments. I have multiple environments because I work in multiple regions, Ashburn and Chicago to be specific. But if you look at one of the regions, and we'll look at Ashburn or Chicago, it's the exact same except for the region is different. And here I can define all the OCIDs, the values. You can see that they're masked. I can say that they're a secret so they don't display them. I can also define variables that are used for password and username, for example. So most of the OCI authentication is going to be done through a series of OCIDs and private keys. But I'm also going to show you an API call that's just using basic authentication, username and password. So this is where you could store that. You don't have to display them and set it up. So one thing that you ought to be sure is if you want to switch environments, you just click on the little plus to the right, and that's the enabled environment that all the API calls will go against in OCI. I'm going to stay with Chicago for now. So if we move over to the collections, I'm going to show you two API calls here in Postman. First one is OCI or OAC, Oracle Analytics Cloud. I'm not sure if you're familiar, but recently OAC product team released a set of APIs which allow you to interrogate the backend catalog environment of your OAC instance. It allows you to get the list of all the items that are types that are available, and then go get all the items themselves. So you can get an inventory of everything that's in your OAC instance. If you work with OAC, you're familiar with workbooks, connections, models, and so forth. And so one of the first calls you want to make is getting a list of available catalog types is what it's called. And here's a REST call. It's a simple REST call. The endpoint is straightforward. There's no parameters on the end. It's a simple get. We're using username and password. Now, if we click send here, you'll see that it returns. These are all the types of artifacts or items that are in the OAC catalog. Workbooks, folders, data sets, connections, so forth. And you can see that it returns that response as a JSON response. Real quickly, I'm going to touch on curl. I don't have a lot to cover there, but as Derek indicated, some people like to use curl. I use curl more if it's for basic authentication, but if it's more advanced authentication, I usually switch over to Postman. The nice thing about Postman is if you want to see your API call in different languages, you can click on this little code icon and it brings up curl. So you can actually copy this, go to a command line, whether it's Linux or Windows if you have curl installed, and you can run this same command and get the response back. If curl's not your thing and you use Java or Python, you can click on any of these different code types and Postman will translate the API call into that language. So I just wanted to call that out for curl. I don't have anything else to cover with curl, but just to show you that. So I just showed you a simple example of calling OAC using a basic authentication. Now, if you get into one of the actual OCI collections, I've been working a lot, and Derek also in the Gen AI services lately, supporting customers. So if you go to the OCI Gen AI service, there's for inference, there's three main areas. You can embed text, generate text, or summarize text. So I'm going to show you a post of generating text. So that's really the same as a ChatGPT. I want to ask the Gen AI service a question. I want to send that to the service and it'll return a response. And so in order to do that, it's a post. It'll go through the inference-based URL that you can get from the documentation. And then the API call is actions/generate text. Now with this call, it requires a request payload. And if you look, or a body. So if you look at the body itself, this is the payload that's defined in the documentation. And in this payload is some important information. First is whenever OCI Gen AI services are run, they're run from within a compartment. So you need to pass a compartment OCID to it. Also, what model do you want to answer your question? OCI Gen AI supports or hosts several models from Cohere and Meta. I'm going to use the Cohere command model. And then the other important piece of information is, well, what's the prompt or question that I'm going to ask? And here I'm just going to say, tell me something about baseball. I'm not going to get into the specifics around tokens and temperature, but that controls how accurate and how much it works to get you an answer. So at this point, I'm going to click the send button. And what it's doing now is it's actually Postman's connecting to the OCI Gen AI service hosted in our tenancy. It's using the API environment details to make the connection. It's passing the payload, telling it to use Cohere, and it's passing the question or prompt, and it's returning the answer. And you can see here, it just gives us a little explanation of what baseball is. And again, this is OCI Gen AI, but if you want to do something on identity or execute a function, or I also did one recently in document understanding for a customer where they needed to extract text from PDFs. You can kick off a job inside of document understanding, which takes PDF files inside of a object storage bucket, extracts the text into a JSON response, and then put it back into a bucket. And again, that's another post job. But again, any OCI service that we support in API, you can call and execute here in Postman. So that kind of summarizes the Postman part of the demonstration. I want to move over to the database, specifically the autonomous database. We work a lot in the autonomous database. A lot of our customers use it and leverage it. And we want to show you some examples of use cases that Derek and I have supported recently around PLSQL and the autonomous database. And some of these are going to be the exact same examples as I just showed in Postman, but I just want to show you how it can be done in different environments. So I have 6 functions I've written that can be called within SQL statements. The first function is to get the OAC items again. And if you look at the OAC API documentation, there's more than just get item types, but I'm just using that one because that's usually the first place we start. And here I'm using the util HTTP package. This is the only example I have using it because if you're in autonomous, I like the DBMS Cloud send request package better. But I just want to show that you can do the same here. And so this is a function. It receives 3 parameters. So what I've done is I've also parameterized my OAC instances and my OCI environments into tables inside of a schema and columns. I did that for 2 reasons. One is you can have multiple environments that you want to interact with, and you can write SQL to do that. Also, it's a way to not display them in your code and access them and control who has access to those credentials. But you can see here, I have an endpoint, and then since I'm using basic authentication for OAC, I'm passing that in as a header. I believe there's other ways to do that, but I'm just using it as a header example here. And so I have to encode the password, username and password So I'm using the util encode base64 function or package to do that. And then I do a get, I pass in the authentication, then I actually make the call. And then when I get the response back, I return it back from my function. So what that looks like in SQL is I have a select statement. And this is what Derek mentioned earlier. Almost all these responses come back as a JSON response. And as you know, there can be a lot of information in the JSON response. It's not very easy to read. The nice thing is the autonomous database has JSON functionality in it, which allows you to translate those JSON values into rows and columns. And I'm using the JSON table function here. And we have another webinar we did, or Derek did, that covers JSON in much more detail. But if we run this statement, it's essentially going to go out, connect to OAC using a REST API call, and then it returns a JSON response. And then it takes that JSON response and makes it look like rows and columns. In this example, there's only one value in one column. So that's the type of catalog item that is returned. That's using HTTP. If you're in Autonomous, you have access to DBMS Cloud package. If you're not in Autonomous, you can install DBMS Cloud into your DBCS environment or your on-prem database. I call out a documentation link in the cheat sheet that I showed you earlier. It takes there's quite a few steps, but it's not that difficult. But you can install DBMS Cloud into your non-autonomous database, which is great. You can do a lot with it. But here's the exact same call using DBMS Cloud send request. It's going to look very similar. I have an endpoint. I have a username and password that I encode base64. The header, the URI, it's making a get call, and then I return it back to the select statement. And again, I'm using just a select statement. Here's my function right here. Then I'm using JSON table to format it into something more readable. In this case, it's going to show you the exact same response or rows and columns as it did before. Now, say you want to work with OCI natively using REST inside of your database. I know it gets a little confusing because you have, not only do we have native REST calls, but we also have SDKs in Python, Ruby, Java, and so forth. But we also have the PLSQL SDK, which we did a webinar on as well some time ago, that you could also write it in. But if you just want to use pure native REST, here's an example of calling the Identity Cloud REST endpoint, passing in a region into my call, along with a credential. And if you're familiar with DBMS Cloud, you have to have a credential. I don't cover that today, but I do provide links in the documentation or in the cheat sheet. A credential is nothing more than the same thing that you would set up for the OCI CLI, or it's a credential that will look the exact same as an environment in Postman. But in this case, we have to define it in the database so that the database can talk to the OCI service. And in this case, I'm going to call the compartments call. I pass us some values saying I want to include all subtrees because compartments can have children within them. And then the actual compartment ID is the tenancy ID of the environment that I want to call. And then if I call that, again, it's very similar, list compartments. If you're not storing these values inside of a table and columns, you could just hard code these values in the call here. But again, I'm using the JSON table. If you look at the payload that's returned, it's going to return all these values for a compartment. In this case, I've reformatted it to using JSON table. And this is live on the fly, going against the tenancy that I have access to. It's returning the parent OCID, the children, the names, the descriptions, when they were created, and the life cycle of the environment or the compartment, when it was, if it's active, disabled, deleted, or whatever. And this would apply for any OCI service that you could make these types of calls. Again, if you want to use another service, GenAI is popular. We've had some use cases around. We want to call the GenAI service, and complement our data with some more data from an LLM hosted by OCI Gen AI. And again, this is not Select AI. That's a whole different feature in the side of autonomous. We have a webinar on that one as well. But this is just natively interacting with the OCI Gen AI service within PLSQL. This will look very similar to the Postman call that I made earlier. I'm passing in the URL to the Gen AI service. I'm making a generate text. Again, I'm passing in a compartment, and then I'm parameterizing the prompt. Well, what question do I want to ask the Gen AI service? And I'm asking this in a SQL statement. So if we move over and we look at the SQL statement I'm calling, very simple. I'm using JSON table to format it. Here's the function I'm calling, Tennessee OCID, Tennessee credential. And then I'm asking, well, who's Abraham Lincoln? So if I run this one, what this is going to do, very similar to Postman, is it's literally connecting to the OCI Gen AI service using the API credential. It's passing in the question, who is Abraham Lincoln? And it's returning a response. Just from a SQL statement. So if you look here, I won't read all this, but it actually returned, information on who Abraham Lincoln was. So think about the use case. If you have information in your database and you want to enhance it with more information from an LLM, you could pass in information from another column into the prompt and get it back. I'm using generate text, but if you have text stored in the database and you want to summarize it, you could use the summarize API call to enhance that information or summarize what's stored in the database. But this is a good example of calling the OCI Gen AI service from the database natively. Several times in the last 6 to 8 months, Derek and I have been asked, well, I have autonomous database, but I have files stored in my AWS S3 bucket. How do I get to it? Can I get to it? The answer is yes. And there's actually multiple ways to get to it. This example shows a simple function that's using a native REST call to go against an Amazon S3 URL with a bucket name and returning all the objects that are in that bucket. In this example, I'm passing in a credential name. So again, you have to authenticate to whatever API call you're making. In this case, I'm connecting to Amazon S3 bucket. I'm also passing in the region, just like Oracle. Amazon has regions that you can deploy in, and then a bucket name. And I'm passing that into the function and then returning all the items that are in my S3 bucket. So what does that look like? Well, here's a select statement. And here's an example of an API call that's not returning JSON. It's returning XML. And so we have you covered. The database has XML table functionality, which will allow you to take your XML and format it to look like rows and columns, just like the JSON table. So this is an example where I'm calling the function AWS list objects. I'm passing in a credential, a region, and then my bucket name. And then I'm formatting it to look like rows and columns. And you can see it's returned the object name, the date that it was created, the size of the object, and then what type of storage class it was leveraged. And that's using a pure native REST call. Now, the nice thing about autonomous, if you're doing your work in autonomous, you have what's called DBMS Cloud. And then you have what's called the get object function. And what that procedure does, very similar to get object from an OCI object storage bucket, you can also do get object from an Amazon S3 bucket. So here's an example of me using the DBMS Cloud get object with an Amazon credential, and I'm going after a specific file. And if I run this, it returns a blob. The cool thing is, just to prove that it actually brought it back, inside SQL Developer, I can look at it and it actually displays the image here. And this is just an image of cars parked in a parking lot. This is actually part of the car parking demo, if you've seen that. But but that's an example of using DBMS Cloud Get Object to bring back something from another cloud provider, since we live in a multi-cloud environment. And then lastly, this is an example of putting it all together. This is going to get a list of all the objects and the object itself into a simple rows and columns. And if you look again, it brings back all the objects along with information on the object in one SQL statement. So that's an example of using native REST calls outside of OCI. We've had quite a few, 2 or 3 use cases where we've had to pull data from other S3 storage providers. And then lastly, this is just a generic call. We've seen where customers they access publicly accessible free data that has no authentication or anything, and inside their database. And this is just a call to Nobel Prizes and list of information. I don't know how accurate or correct the information is, but some people use it to get weather data, stock ticker price information. I just chose to use this one and to show that the credential's null. There's no authentication required. I'm just doing a get, and then it returns some information. And again, this is using the JSON table functionality in the autonomous database to format it into something more meaningful to read. So just to summarize, you can do a lot in native REST within the database. In these examples, I'm just displaying the information back in SQL Developer. But Derek and I, these use cases usually take it a step farther, where they store the data inside the Oracle database, inside of tables and columns, and they store the native JSON data, and then they can query the data through views. So you can create views using the JSON table functionality to make it look very similar to tables, rows, and columns in the table. But again, we're getting the data from a REST call, sometimes third party, storing it in the database, and then querying and formatting to look like rows and columns. And then you could access it using any number of tools like OAC and so forth. So at this point, I'm going to take a step back. I'm done with the demo part of making REST calls, and I'm going to pass it back over to Derek. And Derek's going to walk through some use cases where we're either using the data that we pull back using functions, or interacting with REST data inside of the specific OCI services that are available. There's many of them: OAC, Apex, ODA, just to name a few, Visual Builder, Cloud Service. But Derek's going to walk through some common use cases that we've seen.
Thanks, Steve. Just a reminder, as Steve said, all the code you see here that he's been showing you is all going to be made available as a link on the webinar recording when it comes back. So you don't, here it is. Here it is. Thanks, Steve. So yeah, we usually, when we go code heavy, we put it into some sort of document that you can actually take it and copy it and basically go through and replicate all the stuff that we did. So yeah, I'm just going to show you a couple of places where we actually use REST APIs on the services. As I said, almost every OCI service supports REST API. So, well, why are you picking these ones? Well, these are ones that we're typically doing in Code Innovates. We work a lot with OAC. We work a lot with Apex and some other very common services, some of which I'm not going to cover. But let me just show you how easy it is to consume REST services in OAC. If I go into OAC, and this isn't meant to be any kind of a in-depth coverage of OAC. We have other webinars on that as well. But when you go into data and we go into connections, and you go into connection, I'll just show you what one looks like here. And this is one right on the internet, super, super easy. There it is there. All you do is add the REST endpoint. This particular one doesn't have any authentication. I've got another one very similar to the API that Steve was showing you, is the one on OAC API that came out last year. So I'll show you that as well. It's got authentication, multiple endpoints as well. So yeah, I go in here, I don't save it. I'm going to go into data sets. I'm going to search for SPY. And so I've got a data set here based on the REST endpoint. I can just click on it right here. And yeah, so if I want to go back, don't save, I'm going to create a data set off this. I just click on that. I go into Auto Insights right here. Oracle OAC has a facility to automatically crawl through your data and auto-generate visualizations. Let me add some of these to my canvas. We'll add this one. We'll add this one. Add one more here. They're Auto Insights. And then I can go in here. And if I want to look at this, I can just go here. I can change the visualization type to language narrative. And it basically goes through and uses AI and OAC to take a look at your data. Again, it's REST data. We did this in 20 seconds, very quickly to generate visualizations on top of REST data, either internally or externally, and combine this with your corporate data as well. So if you want to augment data that's available across the internet or in other applications that maybe you don't have control of, use the REST API to do that, join it to your corporate data, do analytics on it. Very easy. We call this mashing the data up. Very, very effective. There's something else I want to show you as well. We'll just go back to the connections. There's the OAC connection. If I inspect it, and you can actually type all this in, but if you can also pass it through in as a JSON file here. So this here, all this connection here was all imported on the connection in OAC, saved me from typing it all. Close. And there's something else I just want to show you as well. If I go into data sets and I go into OAC, I'm having trouble with my UI here. And I've got another one here. Let's open this one. And kind of reinforcing the point that sometimes the services that support the APIs don't support all the services. Database is your friend. So what I ended up doing is I created a data set that used actually a query. And this query is using a REST query in the database. It's returning it. It returns a JSON payload. We use a JSON function. You'll see that here, a JSON function to create the columns that you need. And this is an idiosyncrasy of OAC. OAC returns base encoded values. So I also have a decode function to translate the object path into a text path that you can read. And so how that looks in here. If I go to data, this is basically the same query that's in OAC. And yeah. So yeah, so there it is there. There's the data. And then the base encoded path is right there. And just a point about, I guess, reinforcing the database support as well. I decided when I started working on this, Steve and I both worked on the OAC API. It was actually in support of another customer request. I just put everything in a package. All my header information is in the request type here. I can create snapshots here, and then I just call request type here. I can set the authentication. I also put my username, password, and auth tokens in a separate encrypted table. And now I just pass them in here, the IDCS user, IDCS password. I got the secret, the snapshot string here, which has a credential as well. So I put that in my secrets table. And so you can mask that, and then so I can actually show you the code. And then there's create snapshot, job status. These are things that some of these things Steve was showing as well, but I put it into a single package so I can just call it. Also the encode decode functions. So yeah, the other thing that I wanted to cover is just looking at OAC or in Apex. Apex also supports REST APIs. It has very, very comprehensive support for REST APIs. If you're going to use REST APIs in Apex, you're going to go into utilities. You're going to create your web credentials here. In my case, it's just my IDCS user name and password. I'll go into here. If I go into the application itself, to create a REST endpoint in Apex, you just go into shared component, go into REST data sources. I've got three existing ones. I created this new one here. Let's open it up. It's simple HTTP. It's the server here, the URL path prefix. It asks for the credential. The credential's here. And if I scroll down, it also has a query string. So actually, Apex has got very, very good support for REST APIs. Our customers use REST APIs in Apex applications all the time. And so, yeah, and then how that looks actually similar to what I did in Oracle, in OAC. Let's go into the application itself. Let's go into OAC workbooks. This is a super, super simple, but I'm just showing you how simple it is. You just go into the web, just go into the page, go into a page, create a new page, select the REST endpoint, and I just created a classic report. Oh, great. I created a classic report. And of course, actually, I'm going to skip that part. Trust me. Okay. And my screen is frozen. So I'm going to just, the point being is that once REST endpoints are defined in Apex, they can be used just like any other table. And then the last thing I wanted to show you is give you an idea of what you can do when you have REST API support. This is a Node.js application that exposes the ability to create deployments and run replication between databases in a custom UI. And you could say, well, Golden Gate Services provides a UI already. Why don't you use that, Derek? Well, that was built for developers. It was built for developers. It exposes all the different components, the configuration parts. You have to know what you're doing. But if you want to let actual real business users create replications in a custom application, you can control that. I want to show the databases on a map. I want to show them we have one in Seattle, Denver, San Francisco, Los Angeles, Boston, etc. There's the database names. This is all custom built, all using REST APIs. The user selects the source schemas, the target, and the parameters. It shows the replication details. This is easy enough for an end user to actually define a replication using Golden Gate, which is a somewhat technical, it's a technical solution. It can do a heck of a lot. It's made for IT people, but IT people can build applications on top of that to allow end users to then show the replication of data between remote databases. It's just an example. It's just getting you thinking, hey, if I have REST support on my service, I can create a whole custom application and embed that inside other applications. And then we can do statistics on data that is being transferred, again, retrieving that through the REST API. So with that, I'm going to stop sharing and I'll pass it over to Pete Madura on our team to talk a little bit about where we get all these great ideas, our Code Innovate events.
Thank you very much, Derek and Steve. That great content, great set of presentations there. So again, my name is Pete Madura. I'm an engineer on the Code Innovate team and just want to talk about the program here at Oracle for a few minutes. So the Code Innovate program was originally modeled after a master builder class at Legoland that my manager attended with his children several years ago. The premise of the class was to provide kids a bunch of Lego pieces without any instructions. At that point, a master builder would ask, what do you want to build? And then it would help them design it but the kids would do all the work. And at the end of the class, they would walk away with a new cool Lego creation. So, what is a virtual code innovate? Simply put, it's a program where Oracle engineers team up with a customer to help them build out a first pass prototype for one or more of their use cases. These events are run entirely online and allow your organization to jumpstart their cloud development efforts. So let's quickly walk through what the experience looks like. We start by understanding your use case and the service or services needed to meet the requirements. Next, we pair you with an Oracle engineer that will work with your team. And then by the end of a 20-hour sprint, we'll help your organization build out a first pass working prototype based on your use case. Now, here are some of the simple requirements. We ask that you commit 4 or more developers to an event. And these events typically run for 5 half days or 20 hours. And I would also like to mention that our event start times can be flexible. These events can handle more than one use case. And then we ask for at least 3 weeks lead time to fully understand the use cases, assign the appropriate engineers, and align the schedules. We offer this program for a wide variety of services available on OCI or Oracle Cloud Infrastructure, such as Oracle Digital Assistant, Oracle Analytics Cloud, Apex, or Oracle Integration Cloud, and many more. If you've already got a use case in mind or wanting to learn more about the program, feel free to email us using the address on the screen or simply enter your name and email address into the Zoom chat now. If you're already an Oracle customer, feel free to reach out to your account executive about the program. So thanks for the time, and we hope to hear from you. Back to you, Nikki.
If you like today's session, we'd love to invite you back to check out our other upcoming events. With that, I'll go ahead and close the session.